Welcome to The Bee's Knees, a podcast wild about native bees. Wild and native bees are under threat worldwide. In each episode, we look at actionable things we can do to support these adorable little guys whose pollination work is crucial for maintaining biodiversity. I'm JC Meyer, and I thank you for being here. Imagine seeing a landscape from a bee's eye view. That is what we are going to talk about today with Gwen Kirschke, a PhD student in geospatial analytics at North Carolina State University in the United States. She received a NASA space grant to map floral resources across entire landscapes using airborne imaging and boots-on-the-ground pollinator surveys. Her work blends cutting-edge remote sensing with deep ecological insight to answer a big question. Can we predict where bees nest and forage by mapping the flowers they rely on? So you studied floral nectar production as an undergraduate student and later worked as a research technician on pollinator projects. So what made you apply to a grant from NASA?
Yeah. So when I was applying to graduate school after having done that nectar production work as an undergraduate student, I knew I was interested in scaling up from the types of plant-specific, kind of location-specific measurements that I had been taking to think more about landscapes. And that's how I ended up in my current graduate program. So I'm advised by Dr. Elsie Youngstead, who is faculty in the Applied Ecology Department at NC State, but my degree program is in geospatial analytics. And that degree program has provided me with the background to do the types of modeling that I'm working on here. But even so, even in that kind of new context, it definitely felt like a big leap to apply for NASA funding. And I'm actually really grateful to one of my classmates who heard me present my proposal and suggested that NC Space Grant, which is this funding source that I've gotten, might be a good fit for my work. And then once I started looking into the program's directives, it became clear that this project could fall under NASA's science mission, which covers Earth observation pretty broadly. Yeah, and I'm really glad that the grant reviewers agree.
So you're using aerial imagery to map floral resources. What do you hope these maps will reveal about how bees find food?
Yeah, so in some ways, this at its core is kind of a natural history question. The most direct thing that I'm looking at is how resources are distributed in space. Kind of where are those flowers and how much nectar are the flowers in these different locations producing? But what that allows us to do in relation to thinking about bees and bee foraging is to first identify spatiotemporal research gaps. So that is to say, where in space and time are there gaps in the amount of food that is available for bees compared to how much they might need. And that can be really important in understanding kind of where do they need to go in the landscape? Is there connectivity that's needed? So essentially, if the amount of food in a certain area decreases, they might need to go elsewhere. And are they able to get between those different areas? These types of resource maps are also a really important input for bee foraging models, which is not directly what I'm working on now, but I know lots of other folks are doing that work, and that they need to understand if they're asking kind of how are bees traveling around, they need to understand where are the things that are important to them. And that includes these kinds of floral resource maps.
So bees see the world from above, but most research happens on the ground. How does your project help us understand the landscape from a bee's eye view?
Yeah, as you mentioned, we know quite a bit about floral resources, but almost all of that information comes from individual plants at individual locations, like I was talking about earlier, where that's a lot of the work that I did as an undergraduate and postbac student was taking measurements from specific individual plants. But the bees who are foraging in these landscapes are flying overhead, and they have foraging ranges from between like around 100 meters up to a couple of kilometers, depending on the species. And so the way that they're interacting with these landscapes is at these larger scales. And so having a map like this that's more continuous and at the scale that they're foraging estimate a lot of things that are likely important for their foraging, but difficult to measure with those methods that we've been using that are very site-specific. So, for example, we know that the relationship between the distance to and quality of a resource patch is important, but measuring that, going out and measuring that for like every location that a bee could possibly visit is really impractical and not really a feasible method. Whereas those types of values could be estimated based on a model like the one I'm working on fairly easily.
We talked a little bit about the floral resources, but you're also trying to predict bee nesting rates using this floral data. What would it mean for conservation or farming if we could do that accurately?
Nesting rate is tied to population size. So how many offspring a bee can feed with her limited time that she has to forage during a growing season determines, right, the size of the population in the next year. And from there, right, predicting population sizes is really key for both conservation and agricultural concerns. So questions about, are the populations large enough to sustain themselves into the future? And also, are they large enough to contribute to the types of ecosystem services, such as pollination in an agricultural system, that they can provide? In the current case that I'm working on, we're looking at the nesting rate given the resources that are currently available. That's the map that I'm working on, is about what is currently out there. But a logical extension of this type of project would be to test how the addition of new patches of resources might affect those nesting rates. So, for example, if you add more gardens in a city system, or if you do things like planting wildflower strips in an agricultural area, you could apply similar methods to understand what that might do for the sizes of those bee populations in those areas.
So you've collected a huge amount of data, 480 quadrants, pollen samples, nectar measurements. What's one thing you're most excited to learn from it all?
Personally, I'm definitely kind of most excited at this point to see this nectar map once I have the image in front of me. Way back in 2019, my undergraduate advisor Paul Cardana and I talked about like how cool it would be to have a heat map of where all the nectar was in these meadows where we were working. And at the time, that felt like this really far-flung dream. And now, many years later, I'm getting quite close to seeing that, which is incredibly exciting to me. And within that map, I think I personally am particularly interested in seeing how evenly or not the resources are distributed in space. So again, kind of thinking about that spatiotemporal resource gap question that I mentioned earlier, as well as we are able, because we know what species of flowers specific bee species forage on, we can tailor that map to be the hotspots of resources for those specific bee species. So essentially narrowing down, like, this is just where the flowers that this bee species visit are, and seeing how kind of those heat maps essentially for different bee species might differ is also very exciting to me.
So if you could recommend people do just one thing to support native bees, what would it be?
Try to think about how the resources where you are, like where you're working, relate to those in the broader landscape. So while it's really great to follow the common advice to plant a variety of plants, say in your yard, for most bee species, that's not the only part of the landscape that they're using, or the only part that they have access to. So it can also be helpful to think about what's around. So, for example, if your neighbor or an agricultural field has midsummer blooming flowers, can you be adding species that are blooming before or after that might supplement it, or in other ways kind of make a more holistic landscape that these bees can use? And similarly, are there ways to provide bridges of like small plantings between larger patches to try to increase that kind of measure of connectivity that I was talking about earlier as well?
Gwen's work is a powerful reminder that pollinator conservation isn't just about planting flowers. It's about understanding how those flowers are distributed and whether bees can actually find and use them. By combining field ecology with remote sensing, Gwen is helping us see the landscape from a pollinator's perspective, and that shift in scale could be a game changer. And that, my friends, is a wrap on Season 3. Thank you for spending so much time with me and the bees. We both appreciate your dedication and thoughtfulness. I'll be back in January with a quick update, and Season 4 will kick off on February 3rd. Until then, have a buzz around the website for any episodes or articles you may have missed. Keep buzzing, keep blooming, and I'll see you soon.